Hey, hello, and welcome to the show. Thank you all so much for stopping by. It is time for this week's episode of JP's Product Pick of the Week. And I'm really excited to have you here. I'm very excited about this week's product. It's a fun one to talk about and to show off. And it's going to be a fun one, I think, for people to get at an incredible discounted price because we have it for half off this week. So if we were just talking in the chat about jumping guns. If you want to jump the gun and head right there, do it. This is the QR code and the URL for this week's product pick. If you head there, you can watch this video from inside of there, and you can buy this week's product pick for 50% off. No coupon code is needed. Just put it in your cart and buy it before the end of the show. After the show, we will shut down the discount. So head on over there and check it out. Before I go any further, I'm going to first of all say, yes, it is not exactly what you think. It's kind of what you think. I definitely have a Bluetooth there, but it is not 100% exactly what you think. And so what I'm going to do is have Lady Ada jump back in time a little bit and talk about it, and then I'll tell you why it's not what we all think. All right, take it away, Lady Ada.
The LED driver board for the LED glasses panel that we released last week. These will be in the shop very, very soon. We're just wrapping them up. But it's kind of like a cross between Itsy Bitsy and a feather. But it doesn't have any GPIO. It's meant to be very slim. And it's designed for the LED glasses, but I'll tell you, it's actually kind of a nice dev board if you just want a Bluetooth programmable dev board that's very slim and very minimal. And it has a couple of things built in. So I'm modeling. Who are you wearing? I am wearing the LED glasses driver. Yeah. The glasses driver is on the side here. And again, it's designed to be very slim, so it sits on the side of the glasses. And it has a STEMMA QT port, so it plugs in. You can then plug it into your LED glasses through a STEMMA QT connector. It is just an nRF52840 board. We love the nRF52840. It's a Bluetooth module. It's Arduino compatible. It's CircuitPython compatible. It's very powerful. BLE is supported by every mobile phone, many laptops, desktop computers. So let's go to the top down and I'll show the details. Okay, so here's what we get, because it is a little bit interesting because it's not a standard format. So again, it's as slim as possible. On the right-hand side down here, there's the Bluetooth module. So we've got the certified nRF52840 module. Right here, there's a little mini NeoPixel, so you can do RGB indicating on the side. It's good for the bootloader and stuff. There's also a single LED called LED for blinking. On the bottom there is a 2 megabyte QSPI flash, and so that's used by CircuitPython for file storage. You can also use it by Arduino. Above that is an accelerometer, so you can use it for tilt and motion sensing. Above that is a microphone, a PDM digital mic, good for if you want to do machine learning projects, very minimal ones, audio reactive projects. There's an on-off switch, so it'll turn on-off power to the entire board. There is a battery connector in the center there for LiPo batteries or AAA battery packs. I'm using a AAA battery pack. So there's a LiPo charger circuit, but it's not activated by default. That's because you kind of have to pick one or the other. Either you're going to have LiPo charging, or you use alkaline batteries or nickel metal hydride batteries. But you can't have both because the LiPo charging circuit should not be active. If you have LiPo charging and you have a non-rechargeable battery, you're pushing current into the battery. It's not a good idea, especially with alkalines. It could damage them. They could leak. And so by default, the LiPo battery is not activated. The LiPo charger. So if you go to the bottom of the board, which is the next photo, you'll see on the bottom there's a little thing that says optional LiPo charge. You short that closed with a bit of solder, and that will put power to the LiPo charger. Voila, you can now use LiPo batteries and charge it through. But we thought for the glasses purpose and wearables purpose, a lot of people don't like using LiPo batteries. Okay. Then even more to the left, there's a reset button, and then there's a right angle button labeled SW. That's a user switch, so you can click or double click to have it select things. USB-C for programming it, debugging it, dragging files, charging up the battery if you want to use it. And then all the way to the left, there is a STEMMA QT port. So that's what you would plug into if you want to add external sensors or devices. And then there's 4 slots that you can use to attach it mechanically to whatever you're doing. I mean, it's designed for the LED glasses, but I think there's a lot of people who are like, I just want a simple, small Bluetooth Low Energy board. I can program it with Arduino. I can program it with CircuitPython. It's the well-known nRF52840.
Yeah,
it's got
USB-C.
battery charging, USB-C, on-off, and just a couple sensors, right? Just enough that I can do motion projects or audio projects. And then over the STEMMA QT port, which our Feather and ITZY don't have, you can add other sensors if you'd like. So I think this could actually be a good dev board for other wearable projects as well.
Yeah, that's right. See, it's not what we think. It's somehow different, and I like it. Let's have a look. Here it is. Hey, hey, Slappy, what are you doing here? Let me just try to safely extract that from your mouth. Thanks, buddy. Why don't you get out of here? Never speak of that. There it is. That's my product pick of the week this week. It is the nRF52840 sensor board. This is also known as the LED glasses board because it was originally released to drive our LED glasses like these. In fact, let me turn these on. You can see it mounted there on the side. It's got a AAA battery pack plugged into it right now. It's doing some cool sound reactive stuff. But that's not why I'm here for this today. So forget this thing. Slappy, you can have that. The reason I'm looking at this today is this is an incredibly cool dev board for all kinds of wearable projects and remote projects because it is kind of like Limor said, it's sort of like a Feather, except there's no pins on it. There's no headers for pins or no sockets for pins anywhere on it. So it makes it small. It's got great mounting holes on it. That's one of the things that is tricky about something like the QD Pi is there's no easy way to mount it. This one's got these nice big zip tie compatible mounting holes, so you can run them right through there and lash them to stuff. And it has Bluetooth, BLE capability. You can use that for things like Bluetooth MIDI, Bluetooth HID. It has an accelerometer on it, so you can do tilt kind of stuff. It has that little user switch button there, so you can click on it. You can code it in Arduino as well as CircuitPython. You've got a NeoPixel for status, an LED for status. You can plug into USB-C for coding and power. You can also plug into your battery right next door there. And actually another really nice thing about it is that the ports that you want are both on the same side. So it makes building small enclosures for it really easy. If you have to plug into USB, easy. If you're then keeping a battery plugged or unplugging it for some reason, it's all right there. What else? So unlike a Feather, we don't have any pins on it to plug into things, but we have so many products now that allow you to plug over STEMMA QT port for I2C that this is starting to become really viable for a lot of projects. If you look at a lot of the types of boards that we've been coming out with, sensors and inputs in particular, they use the STEMMA QT, so you don't need to solder stuff. You don't need to put pins on and stick it in a breadboard. So really interesting to consider this as a general purpose dev board. I want to show some demos of it in action. So here I'm gonna switch to my down cam and I'll put a little miniature me here, and I might need to refocus the camera. But what I'm gonna show is, here's my phone. And it's running a little synthesizer program. It's either free or cheap from Moog called Animoog. And then over here I have, whoa, it's making noises. All right, it's gonna make noises. I have our nRF52840 development board there, little sensor board. I am using the accelerometer. I'm using that sensor, and that's actually turning one of the knobs. It's the drive on this filter. In fact, you can watch that knob. Maybe you can hear that if I lean a little closer. And I'm using a nice and easy little plug-in STEMMA QT fader here. So you'll, if you watch those little circles on there and listen to it as I move the fader, all right, and so in fact, let me show you from a different perspective on here. you can see I've got my little phone there that's listening over Bluetooth to what I'm doing with this neat little package. I've got a little LiPo battery under there. I haven't sort of zip tied this together or made it into a neat little bundle, but you can see it's this little handheld controller for BLE. Could be something for HID, for a game input device, for changing the volume on your computer, all over Bluetooth. And we can add whatever little add-ons we want using I2C, and you can chain them, so you can have a bunch of stuff. But I thought this was really cool. Let me turn down the volume on that thing there, or turn off the notes. I thought this was really cool to consider this board as just a dev board and not worry about the glasses part of it. So let's have a look at some things. If we jump over to the web page for the product, you can see here this is product ID 5217. I'll refresh there. Hopefully they're still in stock. We had a lot of them to start with, so you should be good. I think we had over 200 of these in stock. $12.48 US. Great price for this board considering all that's packed onto there. And like I said, you may already have one if you got the ADA box that came with these glasses here. Well, maybe leave this connected and use your glasses as the glasses, but now get yourself a spare dev board or two that you can use for different types of cosplay, props, wireless projects, little tiny gizmos. Another thing I wanted to do is show you a learn guide that Charlene G did. This is a really cool one. This was using the accelerometer to measure when you stop pedaling your exercise bike. And using the Bluetooth BLE, it's sending consumer control to pause your video. So if you're watching something on your iPad while you're biking, when you stop biking, it stops the video. So really nice project. And you can see here she made a cool little enclosure for it, which uses a small LiPo battery, the board, and then that's about it. You've got a couple ports on there for access to the USB, to the battery, the user switch, and then the reset. So if we take a look at the next page here, you can see some nice little shots of that. And that was all Velcroed around the crank on the bike. Here's a nice little stop motion animation. I love this. I should do this more. This is a great way to show how something is put together. So cute. So like Limor said, you do have a little adjustment to make. On the back of the board, there is a jumper there. And by default, that is not bridged. That means it is not going to charge. It's not going to use the charging over USB. And that's just to keep it safe if you're using alkaline batteries. If you are going to use LiPo, then you'll bridge that little solder gap there and be able to charge. What else? Let's take a look at our code for this. So, oh, I've just made all my screens go bananas all over the place. 1 second. DJ Devin said, attach a bunch to yourself and go dancing. Could be fun. So here is, if we take a look, in fact, let me go to, do I have a view where we can also, yeah, let me put this, oh, here's the view I wanted. Hold on. Stuff out of there. Okay, so what I'm going to do is actually plug this one in just so you can see some of the output. I will I'm not playing any notes. You'll still see it trying to do things. You see that knob moving there. But I'm going to plug this into USB just so we can look at the code and look at the output on it. So with this plugged in, you can see there that yellow light turned on. It's now charging. If you take a look at my code over here, I've got basic Bluetooth stuff happening. So I'm importing the BLE libraries that I need and BLE MIDI. I'm importing the Seesaw libraries because I'm using the plug-in slide potentiometer there. And I'm also using the onboard accelerometer. So this List3DH is the little accelerometer that's built on right there, right above that flash. I can zoom in a bit so you can see this better. And if you look in the code window, you'll see down below, I am printing out just the fader values as they happen. I can't remember, I'm also printing out the accelerometer. So you can see I'm taking the accelerometer and remapping that to 0 to 127, which are useful MIDI values. You can also do things like, I think you can do tap detection, so if you just want it to like pause something for you, might do double tap, I can't remember. Or really crude accelerometer stuff like basically flat means something's playing, all the way tilted up means it turns off. That makes it really easy to use it in a wearable context without worrying about the tiny nuances of the accelerometer creating havoc for you. And then there's actually nothing surprising about the rest of the code. It looks like any particularly MIDI Bluetooth type of code. I yanked a lot of it from my MIDI BLE Power Glove project and then made some adjustments and added the fader on there. But it is straightforward to use. You can use it, like I said, with CircuitPython or with Arduino. And it is a heck of a board. So let me see, let me jump over and check if there's any questions or thoughts over in our chats. In the YouTube chat, oh geez, there's some very blue teeth going on there. It's always dangerous to just scroll through this without looking first. Not too dangerous. Yeah, DJ Devin says, if you need Bluetooth and I2C only for your project, it's perfect. Probably also great for LED strips. Change the color with your phone using Bluefruit app. Yeah, you can definitely use Bluefruit app with this. I don't think we have an easy way to connect to non-I2C LEDs because there's not a breakout for a digital pin for using one of our like JST connectors. However, I believe you could tell the pins that are part of the STEMMA QT I2C to act as a digital out. So you would just need to make sure you have a small STEMMA QT connector to your LED strip, but definitely doable. You see how I changed my mind about that as I thought my way through it. Of course you can do that. Let's see, what else? Yeah, I think that's it. Okay, so thanks everyone for stopping by. I hope you like this one. I hope you head on over here and get yourself a bunch because that's a terrific price on a really cool board, a really great dev board, and it doesn't just have to be for your LED glasses projects. So I'm going to go ahead and prepare this one here, throw a little zip tie through it, and that right there is my product pick of the week this week. It is the nRF52840 sensor board, aka LED glasses board. That is going to do it for today. Remember, head on over to that site, that URL right there, if you want to get the discount because it's about to go away. No coupon code needed. Just go and get yourself one or some. I think the limit is 10. And have those on hand for your next Bluetooth dev types of projects. Thanks everyone for stopping by for Adafruit Industries. I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye. It's kind of what you think.